Hi everyone, this is Maverick Paul, the Chemistry Guru. Now in this video, we want to discuss the suggested solution for 2020 A-Levels H2 Chemistry Paper 1 Question 30. Alright, question 30, the last question for this Paper 1. The use of the data booklet is relevant to this question. The table shows some physical properties of metals. One row of the table shows two properties of strontium. Another row shows two properties of vanadium. The other two rows of the table each show one property of your strontium and one property of vanadium. So the question is asking which row shows two properties of vanadium. Essentially, we're trying to compare between these two metals, correct? Between this strontium versus vanadium. We're just trying to compare these two guys. And if I consider the density, the options is between 2.6 and 6.0. So clearly, first thing, I have to determine, okay, between this strontium and vanadium, which one has a higher density? Then melting point, there's also two options, 770 versus 1900. Again, what we will have to do is I'll have to compare between these two metals, which one has a higher melting point. So essentially, it's just comparing these two metals, which one is denser, which one has a higher melting point. Then we decide which will be most relevant for vanadium, correct? So the idea is that. Of course, let us try to locate the position. Where is my strontium and where is my vanadium in the periodic table? So if you look at the periodic table, you notice that your vanadium is in period 4. It is a transition metal. The strontium actually it is in period 5. It's not in the same row as vanadium. So later when we do comparison, we will have to be a little bit careful with that. Okay. First thing, let us consider density. Now, considering density, what we have learned in transition element is if I compare group 2 metals versus transition metal in general, your transition metal will be denser because the mass number is larger, the atomic number is larger, and the size of my transition metal is smaller. So therefore, per unit volume, I can actually pack more transition metal atoms, and it means that transition metal tends to be denser. So if I'm comparing transition metal vanadium versus calcium, in fact any transition metal, scandium, titanium, vanadium, chromium and so on, any transition metal versus calcium, if they are in the same period, then it is very easy. I don't need to do calculation or this, or I don't need to do comparing the atomic radius. I'll just know, because we have learned this explicitly in syllabus, that the transition metal is denser. Density is higher than group 2 metal if I'm comparing in the same row or in the same period. But unfortunately, this exercise makes it a little bit more interesting. Instead of comparing calcium, I'm comparing against strontium. So we want to be a little bit careful with that. And this is the reason why I've also put this information involving the atomic radius for strontium versus vanadium, which is also in the data booklet. The radius for my strontium is 0.215, vanadium is 0.135. And the mass of my strontium and vanadium, we actually also have that. The mass number for your strontium is 87.6 and the mass number for your vanadium is 50.9. So what I'm doing here, of course, this is a very inaccurate way of trying to calculate the density because I'm comparing my vanadium, which is in period 4, and my strontium, which is in period 5. So clearly the size or the mass of your strontium will be larger, which means that maybe you'll make it denser, because the mass is bigger. Density is mass divided by volume. So the bigger the mass, the higher the density. So there is a possibility that strontium, because it is in period 5, it can have a higher density. So what I'm doing is I'm just doing a very inaccurate way of calculating the density. I'll just make use of the mass of your atom. Then I just divide this by size to the power of 3 because your size is in terms of nanometer and volume, it is the radius to the power of 3. So as mentioned, this is a very inaccurate way for me to compare density, but as long as I make use of this formula consistently for both of them, I actually don't really need to determine the actual volume of your atom. I don't need to calculate an accurate density. As long as I calculate them in a similar way, then what we want is we just want to have a sense involving which one the density is higher, which one the density is lower. So again, what I'm doing is I'm working out a rough estimate involving what is a possible density value for each of this metal by using the mass number divided by the size to the power of 3. It's a very loose value. It's very not accurate, definitely not accurate, but it gives me some sense which one tends to be denser. And in this case, you notice the value for my strontium will be about 8,000 something, and the value for my vanadium is about 20,000 something, 20,000 plus. And this would suggest that vanadium should still have a higher density as compared to strontium. We just want to have a very simple and simplistic way for me to estimate the density. And in this case, we know that vanadium it is denser. Alright, next, let us consider melting point. Now, involving melting point, in general, my transition metal should have a higher melting point than group 2 metals because transition metals can delocalize more electrons. It can delocalize its 4s electron, and it can also delocalize its 3d electrons. So I'll have a bigger sea of delocalized electrons, and your transition metal cation will also be more positively charged. So therefore, the metallic bond will be stronger. More positively charged cation attracting a bigger sea of delocalized electrons. The metallic bond will be stronger. The melting point for transition metal will tend to be higher. As compared to group 2 metals, because they can only delocalize 2 electrons, my 4s electron, so I'll have a smaller sea of delocalized electrons, and your metal cation will only be a +2 charge. So +2 charge, less positive charge cation attracting a smaller sea of delocalized electrons, metallic bond tends to be weaker, melting point will be lower. This comparison is a little bit more straightforward, shouldn't give us any problem. I will expect my transition metal, my vanadium, to have a higher melting point as compared to your group 2 metal. So the conclusion that we want to have here is I will expect vanadium as a transition metal. It will have a higher density as compared to group 2 metals and higher melting point as compared to group 2 metals. And if I consider my options A, B, C, D, of course, what we want is I want the density to be higher, 6.0. I want the melting point to be higher, 1900. So my best answer for this question, of course, will be option D. Alright, so that was the discussion involving this exercise. If you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.